Welcome back. This is the last section, but it's a little bit of a longer one, so I'll probably break it up into a couple of videos. So let's talk about the rock cycle. So the rock cycle, I'm sure you've heard of or seen this at some point in your life, whether it's in high school, middle school, elementary school, college, wherever it may be. So the rock cycle is a cycle in which rocks go through. There are three different main types of rocks. There's igneous rocks. Some form underground, those are called intrusive. Some form on the surface, called extrusive. So we have igneous rocks, sedimentary rocks, and metamorphic rocks. They each form differently. Each of these can be changed into one of the other via the rock cycle and all these different processes. Typically, when we start talking about rocks, we start with igneous rocks and make our way around to sedimentary, then metamorphic, but we could really start the conversation anywhere we really wanted to, because this is cyclical. It's a cycle. It goes in any way, shape, or form. We'll come back to this image at the end of this section. So what is the difference between a rock and a mineral? There is a difference. They're both hard. If you threw both of these at someone, they're still going to hurt. But what is the difference between a rock and a mineral? Well, a rock is a naturally formed coherent aggregate of minerals, two or more, usually, and possibly other non-mineral matter. Well, what the heck does that mean? So, in essence, a rock is made up of two or more minerals. That's what it means. So, rocks are typically made up of two or more minerals. You take any two minerals, you kind of smush them together, and in some way, shape, or form, and that's what a rock is. Not always. There are some rocks that are just a single mineral, but those minerals have been altered somehow. So minerals that have been altered or combined, that's what makes a rock. And that's the difference. But the cool thing about rocks is, especially for our class, is they're records of history of Earth's processes. So they can tell us and inform us about past volcanic eruptions, past tectonic activity, earthquakes, what have you. Climate change, landslides, a number of things that we will discuss in this class. So rocks are a good preserver of that kind of information. So rocks are a combination of typically two or more minerals. Sometimes a single mineral altered can make a different type of rock, but in general, it's two or more minerals combined makes a rock. For example, you take some quartz, you take a couple different types of feldspars, orthoclase and plagioclase, and a couple of different types of micas, muscovite and biotite, and you combine those if you kind of melt that material and let it cool to recrystallize, you get granite. You can take that granite, which is made up of these five minerals, kind of grind it down into sand-sized particles, and then kind of cement them together. You get sandstone, which is a sedimentary rock, still made up of this stuff. You take that sedimentary rock, that sandstone, and you heat it up. You don't melt it all the way, because that would get back into the igneous realm. You don't melt it all the way, but you apply enough heat and pressure that it changes and alters the rock itself, and it goes from a sandstone with enough heat and pressure, it turns into a type of metamorphic rock called gneiss, which is still made up of these minerals. So just because they're different rocks, technically, they're still all made up of the same stuff, just altered from one state to the next. So that's how minerals typically make up rocks. Typically, two or more minerals make up a rock. So let's first talk about igneous rocks. So igneous rocks formed by the cooling and solidifying of magma deep below the Earth's surface, or lava on the Earth's surface. So when we have melted material kind of bubbling up through the crust, it's called magma below the surface, and it's called lava once it reaches the surface. It's two different names for the same exact stuff. And we'll talk more about that when we get to volcanoes. But igneous rocks are formed when that hot molten material cools. If that magma stops underground, it cools, forms intrusive igneous rocks. If that molten material makes its way to the surface, it's now known as lava, and it cools down. That would create an extrusive igneous rock. And they are a little bit different, because the type of igneous rock that forms depends on the cooling rate, how fast something cools. Well, the surface of the Earth is much cooler than anything below the surface. Below the surface is much warmer. So if lava reaches the surface, it's pretty cold on the surface, it's going to cool relatively quickly. Whereas if that molten material magma stops below ground and cools, it's warmer, so it's going to take a lot longer for it to cool down. It's just a little bit warmer out there. Sometimes igneous rocks have kind of visible crystals. You can pick out the different mineral grains based on these little different pieces of minerals that you can see with your eye. Sometimes you need a microscope. Sometimes igneous rocks will have vesicles, little holes from air gas bubbles. That tells you a story. So holes in a rock are typically a sign of igneous rock, something that was blown out of a volcano. As this material was blown up into the air and it cooled while it was still flying midair, and it trapped some of that atmospheric gas, or sometimes gas trapped in the lava itself as it's shot out of a volcano. So when you see little gas bubbles, that's definite indication of igneous rock, volcanic activity, something being blown out of a volcano. And it depends. Again, igneous rock depends on if it forms from magma, molten rock below Earth's surface, or lava, molten rock above Earth's surface. So kind of going from bottom up. So if a large pool of magma kind of cools in the crust, this would form an intrusive igneous rock. It would be very coarse grained. It would have big kind of visible crystals. You could pick out the different colored minerals. You see some pinks and whites and blacks, and those are all different minerals that will, in this case, make up something called granite. So that's only produced when magma cools very slowly. As the molten material cools down, as that magma cools, the mineral crystals can grow a little bit. So again, if you're looking at a rock with kind of different mineral crystals in it, that's an igneous rock that cooled below ground. So magma that's cooled. And then you have, I'm going to jump up to C, and that's called a phaneritic texture, by the way. I'm going to jump up to C. So we have a fine grained texture known as aphanitic. That's produced when lava cools on the surface real quick. So when lava flows onto the surface, it's going to cool real quick. It doesn't have time to cool slowly to form big crystals like we would see in this coarse-grained phaneritic texture. So even though these two rocks could be made of the same stuff, it's just that because this lava cooled on the surface real quickly, the crystals couldn't grow big. Maybe under a microscope we'd be able to see them, but with our naked eye, we don't really see much. And then I'm actually going to jump to A up here. So vesicular texture, that's again when something, when lava is rich in gases. So when something's blown out or cools in the atmosphere, it traps gas in it as it cools, forming these little air pockets, vesicular. So these all indicate igneous rocks. Some other ones would be a porphyritic texture. This is kind of a mixture of both of these, where part of it started to cool below ground, so it was magma that began to cool underground. You can see the bigger crystals, and then for some reason the magma decided to get pushed out. Something else, some force propelled that magma out of the volcano, and then the rest of it, the surrounding stuff, cooled later, so it cooled small crystals on the surface. So you get a mix of big crystals and small crystals. That's called porphyritic. And then you have pyroclastic textures produced from debris of an explosive eruption. So a lot of material, as it rains down, it's so hot that it's pieces of this volcano that just exploded, but they're so hot they kind of just weld themselves together, and that creates a kind of a pyroclastic texture. So again, with igneous rocks, what are we looking for? We're looking for crystals, whether they're visible or not. These two rocks are made of the exact same stuff. It's just the molten rock for this one cooled below ground, and the magma cooled below ground to form this kind of rock, which is granite. That very same stuff, if that mix of stuff made its way to the surface and cooled above ground, it forms rhyolite. So we're looking for crystals. Another thing we're looking for in igneous rocks are vesicles, holes, tiny holes created by trapped gas. So that's a great indication of igneous rocks. So what all of these are telling you, if you're picking these up, is that these could indicate volcanic activity. Maybe not so much the big crystal one, but a small crystalline igneous rock. Well, that's lava that's flowed out to the surface and cooled very quickly. All of these rocks have holes, vesicles in them, air bubbles in it. These were kind of rich in gas and maybe exploded out of a volcano. So they're telling you about volcanic activity. You don't even need to know the exact names of these rocks. You just look at them and say, oh man, this one's got air bubbles in it. It must have been shot out of a volcano. By the way, this is vesicular basalt, pumice, and scoria. Some igneous rocks are glassy, very glass-like in nature. Some of you may have heard or seen this. This is a type of igneous rock called obsidian. It cools so quickly that it forms no crystals at all, and it forms like a glass-like texture. Very sharp, but very beautiful glass-like texture. So that's lava that cooled really, really, really quickly. So that's what you're looking for. Again, you don't necessarily have to know the names of these to understand its structure and what it tells you about the Earth. So in igneous rocks, they can indicate volcanic eruptions. If we're looking for microscopic crystals or vesicular rocks or glassy in nature, they can also tell you about tectonic uplift. So if rocks with large visible crystals are at the surface, well, that didn't form at the surface. For instance, if you're out hiking around and you pick up a rock and it's granite, which is an intrusive igneous rock, it has bigger crystals, it cooled below the surface of the Earth. I don't know if I have any around these parts. Let's see here. Oh yeah, here we go. All right, let's get this big. Oh jeez. Oh jeez. All right, so if you're out hiking around and you find something like this, all the different colors you see here, it might be kind of hard to see with the resolution. All the different colors you see are different minerals, crystallized. So this is a big chunk of granite. And I found this when I was out hiking around. But wait a minute, this is an igneous rock, and these big crystals indicate, these visible crystals indicate that this cooled below ground, because it cooled slowly to form those bigger crystals. When I say bigger crystals, you can see them. Well, wait a minute. If that formed below ground, how the heck was I walking around and I just picked it up off the ground? How to get there? Well, there had to be some tectonic activity that lifted and tilted some things to where that granite was exposed to the surface. So sometimes igneous rocks can show you and indicate tectonic uplift, as with a lot of other rocks. So that's the main thing that igneous rocks can show you, mostly on the volcanic side of things. So here's a good range of all different types of igneous rocks and what they show you. Again, some have holes, some have visible crystals, some are made up of big pieces and microscopic pieces. So there's a story there. So for this class, it's not so much the type of rock, but what is the I should say, it's not so much knowing the name of the rock, which can be nice, but it's more so, what is the story that this rock tells us? What is the story? And igneous rocks, the story of igneous rocks, are hot molten material cooling below ground or above ground as volcanic eruptions. So these are a good indicator of volcanic eruptions for the most part. Now, we're going to go ahead and pause here. When we come back, we're going to talk about the other two types of rocks, sedimentary rocks first, and then also metamorphic rocks. I'll see you back here in just a second.